It's happening, it's happening, it's happening. I just purchased this. This is the ASUS version of the NVIDIA DGX Spark. Okay, what is really impressive about this is that it's heavy. Okay, so condensed, so little with so much technology inside. It arrived yesterday. I still haven't had time to plug it, but I will do it. But I'm gonna tell you first what I want to use it for. But even before, I want to tell you this: what just happened. Okay, uh, an insane amount of frustration just because I was working with AI. It kept doing this thing. Okay, let me explain. So in the last 3 days, I've been updating working on the Resonant OS alpha version. A new version is coming out. For those that are new and you don't know, this Resonant OS is an operation system that run on top of OpenClaw. What it does, it resolves a series of problem that OpenClaw has, including the memory, but allow AI to actually follow the rules. And this is the funny thing, okay? So what it does as a logician, they create a series of rules and gates that deterministically force the AI to follow those rules. In this way, we have a 100% certainty that something should be done in a precise way, unless you don't have the rules, and therefore it's how do you call it? It's a probability to happen. Okay, and that probability to happen is the most frustrating things. First of all, we need to understand one thing: we can't have rules for everything, and sometimes we build rules for things that are repetitive or a constant, let's say. Okay, there is a precise protocol to do something, but sometimes we work on things that need to be done once, or the protocol needs to be loosey because I need to do things a different way. One of those is me updating things on the GitHub, pushing the new code there. So we've been working 3 days to create this new version of ResonantOS. Okay, version 6 of the alpha, refactoring all the code, structuring the code better and so on, adding how do you call it, the sanitation to, I think it's called like this, sanitation to the code itself. So the code, there is information inside the code, so AI and the human can read it and understand what the code does. So citation, that's the word. Adding citation to the system. So the whole thing, 3 days working and so on, okay, a lot of things. And then I say to the AI, okay, now that it's tested, verified, okay, commit to push it to GitHub. It does, and I say, you're done, sorted, fixed it. And then I just thought, let me check what it did. And it pushed the wrong version of the alpha, the old version. So it pushed the old version with some documents of the new one, just to just to mess it up a little bit more. And it's so frustrating. I wanted to destroy the whole world, to just take the computer, just break it apart. Now, it's an easy fix. It's just now he's working on it. Okay, I just explain again. Look, what we are pushing is the work that we've done in the last 3 days. That is the version that we need to push. I don't want to see anything from the older version. So now is doing it, and of course. Of course, it's gonna go live, but the frustration is insane. Okay, this something that for us as a human is it's so easy. Okay, you would never get confused with a work done weeks ago with work done with 3 days ago, but AI can do this. Okay, the reality of the AI is so unstable. Okay, a little word, a little misunderstanding, loading the wrong chunk of memory from the rack system, and then that thing pollute everything. It's like a prompt injection that give the wrong data, and therefore the AI get completely lost. Unfortunately, for these kind of problems, there is not really a solution. In the sense, this is the technology that we are dealing with. Okay, it's not smart enough, and it's totally probabilistic. So we can add elements to, to make it behave in the correct way, system that check if the system is working correctly, and so on. But it's basically, at the moment, it's not really possible to have 100% certainty. And that is, and it's not how good you are with prompt engineer, it's not how good you are with architecture. This is the reality. Okay, there is no one, don't trust the one that tells you, no, 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 I can do it. There's nobody that can have 100% certainty on a probabilistic system. And this is confirmed by all the major and minor AI labs, OpenAI, Anthropic, Gemini, from the so much that Anthropic told to the government, to the Department of Defense or Department of War, that is not reliable to give total autonomy to AI, okay, on weapons. So that is the reality. So don't trust anybody that said, no, 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 I can do it, I can do it. It's not possible. Okay, what you can do is get closer and closer. On specific elements, you can become really, really close. On simple things, you might reach certainty. But on real work, okay, which is not simple, okay, it's advanced, it's complicated, and there is a lot of unknowns and things that keep changing and moving. In that reality, you are impossible, in a position where it's impossible to trust AI is going to do the correct thing. So frustration, massive frustration is there. The ResonantOS has this beautiful thing. Okay, when a mistake keep happening, it just understand. Okay, we need to turn this mistake into a skill, into a protocol, into a rule for the logician. We need to implement something that this remove the likeliness of happening again. So you can turn the system to become more biased towards a specific behavior. Again, on some scenario, it's possible to create a gate, okay, and say yes or no, you have this or not, and therefore only the correct answer would go through. That is possible because you can create a deterministic gate through the logician and have exactly the right result. But no, it's not always possible complex thing, because there is complex things doesn't mean there is yes or no. Okay, yes or no, do you have a screenshot? Yes or no is correct. The logician, so a deterministic system cannot know if that is correct. Okay, needs to look inside, needs an intelligence to interpret if the file is correct. So you ask AI, send me a screenshot. The AI cannot send you something random, it needs to send you a screenshot. But the logician will stop if it's not a screenshot, so it's a text file, if it's something wrong. Okay, we stop it, but the content inside cannot be tested. Okay, that is required intelligence. That intelligence cannot be trusted. So it's really likely that you ask a screenshot, it's gonna do the screenshot and give you the screenshot. It's pretty likely because it's really simple. And that simplicity it's almost certain, even though it's never certain, but almost certain that it's gonna work. So that is the frustration, and it's never stopped. Why it never stops is because AI never learn. It cannot learn. Okay, it cannot improve. We can improve the architecture, but not the LLM. Now we have this. Okay, what is this for? This is the, like I said, is the equivalent of the NVIDIA DGX Spark. Okay, what this can do, what this machine can do, is a mini AI lab. Okay, I can train AI, I can fine-tune AI models. Okay, I can use these to create a specific small AI. Okay, because this is, of course, even though it's expensive, I have to say, even though it's expensive, but it can work amazingly on small AI model. Now, we can't train a massive AI model, but we can train AI model that can run on this machine, on a smaller, larger machine. But what is the advantage? That now I can create a specific agent that does one specific functionality really well. Again, just to connect to the example of if it's a screenshot. Okay, that specific agent can be fine-tuning, understanding if it's a screenshot or not. Okay, so if it's fine-tuned there, so the chance that even though it's probabilistic, that AI is really biased towards a specific behavior to recognize specific patterns, and therefore the chance that to be correct it goes much higher than a large model that is trained to do anything. Okay, so therefore can get confused about everything. So that is what we can do now. And so what's my idea? What's my idea with this? The idea here is, first of all, I want to create a small model that can manage and work together to help this OpenClaw to run in a better place, okay, to run properly. So at the moment, what we have, for example, for the memory, we have a sort of generic open source model that run locally on your computer if your computer is powerful enough. Run locally. For example, my Mac Mini, it runs locally, and this agent, this LLM, what it does is just look after the RAG memory, okay, retrieve the information. Okay, such an important job, but retrieve the information. This agent is really small and not fine-tuned for this specific work, or not fine-tuned on my specific work, let's say. So we can create now, through this machine, an LLM that is still really small, but really work well with OpenClaw, RAG memory for that specific system. Okay, that is what we can do. Now, this example, it might be not the ideal example, okay, but it's to give you an idea what is possible to do when you have a fine-tune. So you create an AI, a model that is perfect for your use case scenario. Some of those models that I will fine-tune will be for my community. Okay, so the community, they use ResonantOS, they use OpenClaw, and so on. So I will fine-tune them and then share with everybody. But then I will do also fine-tune model for myself. Like, for example, just to make an example, okay, you can hear that I have this Italian accent. Okay, some people say this beautiful Italian accent. Okay, I got this beautiful Italian accent, which AI sometimes doesn't get it. And so what I can do, I can now train AI with my accent. Okay, so it's gonna learn how I pronounce some words, and then it's gonna know, it's not gonna make mistakes and hallucinate meaning out of what I say, increasing the quality of the transcription between audio to text. So higher quality, okay, more precise information, better output. Just to give an example, okay? But then there is other things that can be done. But before I explain those things, and I will do some video that I will explain exactly what I can run with this machine. This is, like I said, is the ASUS version of it. There are other brands that do it. What is good with this one, from my understanding, is first of all, it's cheaper than the NVIDIA. Second, it has a better cooling. But the hardware itself, it's exactly the same. It's not like they do different hardware. What they change is minor parts. One thing that I want to say, this is what I want to say. Those videos that I will do, I will share the real data about the speed of this. Okay, have in mind that this has 128 gigabyte of RAM that is shared with the CPU and GPU, so can run pretty large models. But now I've got a phone call, I need to pause or stop. I'm back. So what we were saying, it's I forgot because I'm back, but it's past an hour. So that is what I don't know what I'm saying. So I don't know, but I'm gonna come back from this. So this is what I'm gonna use, and the idea is to build those custom local AI for help the community with OpenClaw, but also create some custom AI for my specific needs. But what I want to test, this is important, this is what I wanted to say. So what I wanted to test is if I can run OpenClaw 100% locally. So let me explain what's the challenge, because this machine can do it, but there is a difference between an AI that you use in the background, that you allow to you to work 24/7 on experiment, on stuff, okay, and therefore you don't need speed. But if you want to chat with this AI, okay, the moment that you chat, you need some certain amount of token per seconds. So that is the experiment that I want to tell, because I did research. Nobody tells you, let's say that nobody tells you the truth, because everybody say, yeah, it's good enough. Good enough. What's good enough? Okay, it's. I want to know if I can work. Maybe when I'm gonna do the video, I'm gonna say again, it's good enough. I'm gonna be one of those. But no, I'm gonna say the truth about this, because this channel is not about the hype. Okay, I don't need to sell anybody anything, and not even hype. I will tell you if this machine probably running or Nemotron 120 billions plus another small model, because you need always two models to run correctly OpenClaw. So one larger model for reasoning and so on to work properly, but this is going to be slower, and one smaller one that is going to be faster because it's smaller for fast task. Okay, heartbeat, cron's jobs, and the memory things. Okay, all those simple stuff is going to be done by the smaller model, but the one that you need to talk with, you want a high intelligence, so it's going to be the bigger one. So the bigger one, 120 billions, can run on this, and those two models, 120 and 30 billions, should be able to run simultaneously on this machine. The problem is the 120 billion might be slow. So how slow? How is it slow that you can work with it, or slow that you don't want to work with it? Okay, that's what I want to test. The 120 billions, there are two models that I'm interested to check. One is GPT OSS, I think it's called, 120 billion, and has the version also, the 20 billion one. So you can put them together. And here is this Nemotron 120 billion and Nemotron Nano 30 billions. That's what, if I'm not wrong with numbers, but those are the reality. Both of them, even though they are 120 billion, they actually load, maybe I'm not precise with the wording here, it's something that I'm learning, okay? So, but they work with 12 billions at the time. So meaning they can be faster. Now, probably it still doesn't make sense to have an OpenClaw completely local. But it's nice to know that it's possible to do it and have it. Okay, so at least you say, okay, I have a local OpenClaw version running with ResonantOS, therefore optimized and so on, that you can trust. But it's probably, my feeling here is that it's probably better to to have a subscription with someone and have a really high level model. This is for now, but the learning process is really interesting. Having the option to run locally, no internet, World War III, whatever scenario happening, whatever it is, now I can have my local AI that I can use, and with data and so on. So that is it's something interesting to experiment with. So if you're interested, of course, like and subscribe this channel. I will tell the truth that I couldn't manage to find on any channel. They all say, they give you some numbers, but the benchmark is I don't care about the benchmark. Okay, what I care is the human interaction. Do I feel frustrated in working with something that is too slow or not? Okay, we all using these cloud corporate AI. They are pretty fast. Okay, probably it's going to be faster than anything that can run on here. But what the point here is, when the frustration starts, okay, it's slow but it's workable, or it's slow and I'm never going to use it. Okay, that is the difference. Nevertheless, even if I'm not going to use it for chatting, which is not the reason why I bought it, is the point here is having a local AI that can work 24/7. Okay, you don't pay tokens, you pay electricity, and those machines are not super power hungry. But I have solar panels. Okay, so this is gonna run through the solar panel during the day, charge through the battery, during the night. So it can run 24/7, never stop, always working. And now the challenge here is to build this AI that what kind of project they should run 24/7. I have a few ideas. I will share those ideas, but I have a few ideas that can be not just one single job, but different jobs they can be done over a day, and then carry on, 24/7. I don't know. So I'm super excited. One thing to consider here is that the data for training requires space. To do experiment, want to do, you require space. So the internal storage is never going to be enough and shouldn't be used for storing data. It should be used to storing software and LLMs, okay, AI models. So they are fast to upload in the system, but not for storing data. So for storing data, you need an external drive. I have a few. I have also a NAS, so through network I can connect, and I can't wait. I can't wait. So I will keep you updated on this. Again, like and subscribe. There's going to be a deep dive article connected to this video. And thanks again, and see you. One more thing. So every Wednesday, Thursday, we have Zoom call with the community. Join the community on the Discord, but there is the Zoom call where we discuss AI from both the technical side on Wednesday and the more philosophical, more high thinking on Thursday. 8 p.m. Central European Time. Europe is going to change the time zone, not the time zone. It's going to move to summer time, so summer saving time, I think it's called, and therefore the time is going to change, okay? But it's going to always be 8 p.m. Central European Time, or Central European Summer Time. Okay, do some math, join the community, and you will never go wrong. Ciao, ciao.